What is the limit as x approaches infinity of the square root of 4x squared plus 12x plus 3 minus 2x? The expression is in the form infinity minus infinity because 4x squared plus 12x plus 3 tends towards infinity as x approaches infinity, so the square root of that expression also tends towards infinity as x grows larger. 2x also grows without bound as x approaches infinity, so the entire expression is in the form infinity minus infinity, which is an indeterminate form, so we need to do some more work. So first of all, will this even converge to a single real value, or will it keep on growing either towards infinity or negative infinity? If we look at it informally, we can say that in the quadratic expression, 4x squared plus 12x plus 3, only the leading term, which is the term with the highest exponent, really matters as x grows towards infinity. So the square root of 4x squared plus 12x plus 3 is approximately the square root of 4x squared, which equals 2x. So the square root of 4x squared plus 12x plus 3 seems to grow at the same rate as 2x. So it would seem reasonable to conclude that square root of 4x squared plus 12x plus 3 minus 2x should converge as x approaches infinity. However, we would actually like to formally prove this using algebra, and the observation alone doesn't tell us which real number it converges to, so we would also like to work that one out too. So what we should do is multiply both the numerator and denominator of the expression by the conjugate of the square root of 4x squared plus 12x plus 3 minus 2x, which is the square root of 4x squared plus 12x plus 3 plus 2x. Well, technically, the original expression in the limit wasn't a fraction, but you can think of it as a fraction, where the denominator is 1. If we use the formula a plus b times a minus b equals a squared minus b squared, the numerator becomes the square root of 4x squared plus 12x plus 3 all squared minus 2x all squared, and the denominator stays the same. The square root and the square cancels out, and 2x all squared equals 4x squared. So this simplifies to the limit as x approaches infinity of 4x squared plus 12x plus 3 minus 4x squared all over the square root of 4x squared plus 12x plus 3 plus 2x. The 4x squared and the negative 4x squared cancels out, so the numerator simplifies to 12x plus 3. The next thing we should do is to divide both the numerator and the denominator by x, so the leading term in the numerator becomes a constant. Each term in the numerator is divided by x, along with the 2x term in the denominator. Each individual term inside the square root expression itself is divided by x squared because when we divide the entire square root term by x, it's equivalent to dividing by the square root of x squared, and the division is distributed into each individual term in the square root. If we divide 12x by x, we end up with 12, and 4x squared over x squared in the square root turns out to be 4. 12x over x squared is just 12 over x, and the 2x divided by x in the denominator simplifies to 2. So this entire expression simplifies to the limit as x approaches infinity of 12 plus 3 over x, all divided by the square root of 4 plus 12 over x plus 3 over x squared plus 2. If we plug in infinity to this expression, the 3 over x, 12 over x, and 3 over x squared terms all become 0, since in each of these terms, the numerator is a constant, while the denominator tends towards infinity as x approaches infinity. This leaves us with 12 plus 0 all over the square root of 4 plus 0 plus 0 plus 2. This simplifies to 12 over the square root of 4 plus 2, which simplifies to 3. So the original limit is equal to 3.